In this video, I'm going to solve some MCQs on fats and lipids. This is the part 2 of the Solving MCQ series. If you have not watched the introductory session of this video, of this series, I would highly recommend to please go down in the description, click on the link and watch the introductory session. If you have watched it already, then let's continue. In the previous video on carbohydrates, I asked you a question. I gave you a homework. करके लाए हो? खाना खाना तो नहीं बोलते. So the question was, how are you going to differentiate between a reducing sugar and a non-reducing sugar if you have been given some chemical reagents like Feeling solution A and B or Benedict's solution? So the correct answer has been given by Shivangi Sharma. She has mentioned the correct answer and I'm really glad that she mentioned it. I will also indicate her comment over here. Kudos to you, Shivangi Sharma. This is the correct answer. Alright, now moving on to the questions of fats and lipids. So the first question for you is, lipids are dashed in water but dashed in non-polar solvents. The options are A, soluble, insoluble, option B, insoluble, soluble, option C, both of them are soluble, and option D, both of them are insoluble. So lipids are, what are they? Are they soluble in water or are they insoluble in water? Let me give you a brief background on non-polar solvents. So there are two kinds of solvent. The one is polar solvents and the other is non-polar solvents. Now, the polarity is a concept that you should have studied in class 11th or 12th, but I will just give you a brief background. So the polarity. So a molecule has polarity, high polarity, or we call it polar molecule because the electronegativities of the atoms present in that molecule are very different. Right. So let's say that there is a water molecule and water molecule is called a polar molecule. Why? Because the electronegativity of hydrogen atom and oxygen atom are very different. But in case of, let's say, chloroform, the atoms are present, the electronegativities of the atoms are very similar to each other. So that is why we call chloroform as a non-polar solvent. There are some other examples as well, like benzene. So in benzene also, the electronegativities of the atoms are similar, are close to one another. That is why we call it as a non-polar solvent. So the lipids are insoluble in water. So that means if you want to mix a lipid in water, it will not dissolve. And if you want to mix a lipid in a non-polar solvent such as carbon disulfide or benzene or ether or chloroform, it will dissolve easily. So the option B is the correct answer. Moving on to the second one. Unsaturated fatty acids get option A, reduced easily, option 2, oxidized easily, option 3, both A and B, and option D, none of the above. So the unsaturated fatty acids get oxidized easily, not reduced, they get oxidized easily. There is nothing much to explain in this question, so I'm moving on to the third one. Saturated fatty acids are more, option A, oxidizable, option B, reactive than unsaturated fatty acids, and 3, storable, D, none of the above. So see, saturated fatty acids, and there are two kinds of fatty acids, saturated and unsaturated, right? So the saturated fatty acids are usually present in the atmosphere, in the environment, in solid state, right? Some of the examples of saturated fatty acids are like butter, ghee, animal fat is one of the examples of saturated fatty acid. Whereas on the other hand, unsaturated fatty acids are usually liquid at room temperature. For example, sunflower oil or flaxseed oil, right, mustard oil, these all are not saturated. These are unsaturated. So in this question should have been like this. Saturated fatty acids are more dash than unsaturated fatty acids because more is like a comparison, right? So the option C is the correct answer. Saturated fatty acids are more storable. Also, I want to apologize for this question because it should have been saturated fatty acids are more storable than unsaturated fatty acids, because obviously saturated fatty acids will also tend to spoil at some point in time. So what are we comparing saturated with? We are comparing saturated fatty acids with unsaturated ones. So in comparison, saturated fatty acids are more storable because they are usually solid at room temperature. Moving on to the next one. 1 gram of fat gives 7 kilocalories, 9 kilocalories, 4 kilocalories and 8 kilocalories. This is very easy and you should know this by now. So the second option is the correct one. If you consume 1 gram of fat, you will get 9 kilocalories. Moving on to the next one. So butyric acid is found in option A, butter, option B, flaxseed, option 3, corn, and option D is refined oil. So the correct option, what do you think the correct option should be? The correct answer is butter. So you can memorize this by keeping in mind that butyric, the starting three letters are BUT, and the starting three letters of butter are also BUT. So you can memorize it in that way. Okay, that butter has BUT and butyric acid also has BUT. So that is why butyric acid is present in butter. So these are just facts, and some of them are facts and some of them are concepts. For the facts, you have to just go for plain memorization, plain old memorization. Moving on to the next one. Linolenic acid is also known as omega-3 fatty acid, omega-6 fatty acid, oleic acid, and the final option is 9-octadecanoic acid. So there are two kinds of fatty acids again, and the first one is non-essential, the second one is essential. So the essential fatty acids, our body cannot synthesize essential fatty acids. That is why we have to consume essential fatty acids from our diets or from the supplementations. But the non-essential ones, our body can synthesize, our body can manufacture or produce non-essential fatty acids. That is why they are not so much important. Since we can synthesize that, since the human body can synthesize that, we don't necessarily need to consume that from our diet. That is why they are non-essential. So linolenic acid is an essential fatty acid, right? So the correct option, what should be the correct option? So the linolenic acid is also known as option A, omega-3 fatty acid. Why do we call it specifically 3? Why not like 1, 2 or 5 or 6? So let me give you a background on this as well. So in a fatty acid molecule, what happens? There is a long chain, right? There is a long chain of carbon atoms and hydrogen atoms. At the one end of the fatty acid chain, there is a CH3 group. CH3 group is also known as methyl group. And on the other hand, there is a carboxylic group. Carboxylic group, we can also write carboxylic group as COOH, right? So these two functional groups are present at the opposite ends of a fatty acid chain, right? So why do we specifically call linolenic acid as omega-3? Because the first double bond that is present in omega-3 fatty acid or linolenic acid, if we start from the CH3 group, so the first double bond is present at the third carbon atom, right? Let me repeat it once again. The first double bond is present at the third carbon atom when we start counting from CH3 group, and that is why we call it as omega-3 fatty acid. Same principle is applied for linoleic acid. Linoleic acid is known as omega-6 fatty acid. And why do we call it 6? Why do we mention 6 specifically? Because the first double bond in linoleic acid is present at the 6th position if we start counting from the CH3 group. Alright, now moving on to the next question. Specific gravity of fats is option A equal to 1, option B less than 1, option C greater than 1, option D none of the above. So specific gravity is also known as relative density, and specific gravity, the formula of specific gravity is the ratio of the density of a substance divided by the density of a relative substance. And in most of the cases, that relative substance is water. So in case of water, the specific gravity of water will be 1 because the density of water is 1, and if we divide 1 by 1, the answer is simple, it will be 1. So specific gravity of water is 1. But the specific gravity of fats is less than 1. This is one of the reasons why fat floats on water. If you just like pour oil on a glass of water, it will float on top of the surface of water. And that is because of the specific gravity. The specific gravity of fat is lesser when compared to specific gravity of water. That is why fat or oil floats on water. Now moving on to the next question. Example of saturated fatty acids. Option A lauric acid, option B oleic acid, option C stearic acid, option D both A and C. Now lauric acid is a saturated fatty acid. Oleic acid on the other hand is not a saturated fatty acid, it is a unsaturated fatty acid. Stearic acid is a saturated fatty acid, therefore the correct option is both A and C. Both lauric acid and stearic acid are correct options. So option D is the correct answer. Moving on to the next question. Dash converts vegetable oil to a solid shortening. Option A saponification, option B rendering, option C hydrogenation, option D neutralization. Now the correct option, and this is also an easier question because most of you must have studied this in class 11th or 12th. So the correct answer is hydrogenation. Let me give you a brief background on hydrogenation. So the hydrogenation is a process which is widely used in oil industry, especially in the production of margarine or partially hydrogenated products like dalda ghee or rat ghee. So in hydrogenation, what do? We add a hydrogen molecule or hydrogen with unsaturated fatty acids like vegetable oils. And why do we do that? We do that to extend to make a new product. It could be either margarine or any partially hydrogenated product. And we do that in the presence of a catalyst like nickel or platinum or palladium. Right. Next question. Transform of oleic acid is option A, allylic acid, option B, gluconic acid, option C, myristic, option D, butyric acid. So this is also, there is no concept behind this question. That is why I'm not going to explain it in depth. The correct answer is allylic acid. Moving on to the next one. Higher the iodine value. Option A, lower the unsaturation in fat. Option B, higher the unsaturation in fat. Option C, doesn't affect unsaturation. Option D, none of the above. So iodine value represents the degree of unsaturation in fats, right? So the option B is the correct one. So higher is the iodine value, higher is going to be the unsaturation in fats. Remember that. Also, there is a homework for you for this question. How are you going to determine iodine value if you are present in a food chemistry lab? Comment down below. Now moving on to the next question. Degree of oxidation in fat can be expressed as option A, peroxide value, option B, iodine value, option C, saponification value, and option D is solid fat index. That is not D, that is F, solid fat index. So peroxide value is used to determine the degree of oxidation. Again, there is one more homework. Add this to your diary. I want you to comment below what is peroxide value apart from degree of oxidation. Obviously, peroxide value is the degree of oxidation in fat. But how are you going to determine peroxide value? What is the technical definition in terms of food chemistry? I want to know that. Comment down below. Next question for you. Average molecular weight of fatty acids is indicated by 1. Acid value, option B, saponification value, option C, anisidine number, and option D, Polinsky number. So saponification value or saponification number is the correct answer. Option B is the correct answer. Third homework for you. The third homework for you is you have to define saponification value, the technical definition of saponification value. Obviously, this is average molecular weight, but I want the definition which is correct in terms of food chemistry, in terms of food analytical chemistry to be more precise. Moving on to the next question. Fats containing saturated fatty acids are option A, solid at room temperature, option B, liquid at room temperature, option C, intermediate state, option D, does not depend on saturation. The hint for this question was mentioned in this video. If you have been watching carefully, if you have been observing carefully, if you have been listening carefully, you should know the answer of this question by now. So fats containing saturated fatty acids are solids at room temperature. I just gave the example in the beginning of this video. I gave the example that saturated fatty acids are usually solids at room temperature. That is why they are more storable. Some of the examples of saturated fatty acids are butter, ghee, and animal fat. These are the examples of saturated fatty acids. Alright, so this was it for today. These were the questions. I hope this video added some kind of value to your life. Make sure you do the homework. Right, make sure you do the homework. Comment down below your answers. If your answers are correct, I will mention them in the next video. Subscribe to the channel if you have not already. Hit the bell icon as well. And comment down below if you have any kind of doubts. I will make sure that I reply to most of you. And I will see you next time. Class dismissed.